Hey everyone, in this video we are going to be discussing about the periodicity of the properties, and this is basically a topic which is taken from your chemistry book chapter number 3, which is a periodic table and periodicity of the properties. So basically, as I've told you, that all the elements that are present in the periodic table, they are arranged according to the increasing atomic number, right? So it means as the number of atoms, as the number of the electrons are increased, what happens is that electronic configuration of the elements also changes. So this electronic configuration is a main thing that describes the different properties, right? So the chemical property is one of the properties that is basically depending upon the valence shell configuration. It means that if the valence shell configuration is changed, then what will happen? This chemical property will also be changed. Okay, so valence shell electronic configuration. Okay, so chemical properties depend upon the valence shell electronic configuration, and the physical property depends upon the sizes of atoms. Okay, now let's discuss them in great detail. Okay, so the chemical properties are depending upon the valence shell electronic configuration. Okay, now first let's take example of the groups. So what happens is that as you move from top to bottom, what happens is that the electronic configuration of the valence shell remains the same, as I've told you in the previous video. Okay, in which we discussed about the shape of the periodic table. What we said is that all the elements that have the same valence shell electronic configuration, they are placed under the same group, right? For example, we had hydrogen that was having the electronic configuration of the 1s1. Then we had sodium, which has the electronic configuration of 2s1. Then we had magnesium. Sorry, this was hydrogen, lithium, and sodium, potassium. Okay, yes. So it goes like this. So sodium has 3s1, potassium has 4s1. So here you can see that s1, 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 s1. So these are all showing you the valence shell electronic configuration, right? And in all of these elements, we can see that this electronic configuration is same, right? Because they are placed under the same group. That is why this valence shell electronic configuration is same, right? So it means that the chemical properties, when we move from top to bottom in a particular group, it doesn't change because the valence shell electronic configuration of the elements do not change. That is why what we have concluded, that chemical properties don't change, they remain the same. Okay, then if we move along the period, what happens? Let's see. Now as you know that as we move along the period, what happens is that the group number of the elements gets changed. That is why the successive elements that are coming along a period, they would have one electron added to their outermost shell. Okay, for example, if we take the example of boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so this basically starts from the group 3, 4, 5, 6, 7, 8. Okay, so that is how it goes on. So here you can see the group number is changing. So group number was telling you that how many electrons the element has in its valence shell. So boron would have 3 electrons. Carbon, as it belongs to this fourth group, so it would have 4 electrons. Nitrogen belongs to the fifth group, so it would have 5 electrons in its valence shell. Then oxygen belongs to sixth group, so 6 electrons. So it means that as you are moving along a period, what happens is that the additional electron is added. Okay, the one more electron gets added into the successive, the next coming electrons, right? So it means that as the valence shell electronic configuration is changing with element to element, so you can say that the chemical properties are changing, right? So here what you can conclude is that the chemical properties change when we move along a period, right? Now let us talk about the physical properties. So as I've told you that the physical properties depends upon the sizes of the atoms, right? So let us first see that how the sizes of the atoms change when we move along a period and when we move from top to bottom in a group. So first of all, let us see this thing in the group. Okay, so first what happens in a group is that, as you know, when we move from top to bottom in a group, you can see that the number of the shells are added, okay? Because the period number is changing here. This is first period, so it means that hydrogen would have only one shell, okay? So lithium belongs to the second period, sorry. So it would have the two shells. Then we have the sodium, as it belongs to the third period, so it would have the three shells. Okay, it is getting a bit messy here, but I hope you're getting it, okay? So it means that as we are moving from top to bottom, the number of shells are getting increased. So what this shows you is that the size of the atom would also get increased, definitely. As the number of electrons, as you know that the more the number of electrons are there, it would have the repulsion, okay? So, and definitely the nucleus would have less attraction for the outermost shell, okay? Let me illustrate you here. For example, if this is the first shell, okay, if this is the first period, so definitely the element would have the one outermost shell, okay. Let's say it is example of the hydrogen. This is the nucleus of the hydrogen and this is the outermost shell of the hydrogen, and here is the only one electron that it has in the valence shell. So as you know that here, as the hydrogen has only one shell and only one electron, so this would have the greater attraction towards the nucleus, right? But as you can see, the number of the shells are increased, what would happen? For example, okay, so these are one, two, three shells. So suppose that this is the atom of sodium, okay? So this is the nucleus and this is the outermost shell. Now, if there is one electron placed here, is it closer to the nucleus? No, it is moving apart from the nucleus. So it means that the force of attraction would be very much less as compared to the hydrogen or any element that is above the sodium, right? So hence we can say that as we move down the group, or as we are moving from top to bottom, what happens is that due to the increased number of shells that are added to the successive elements, what happens is that the size of the atoms become increased. That is why if the size of the atoms are increased, so the physical properties are also increased, right? Size of atoms are increased and the physical properties are also increased. So here you can say in the groups, where you can say the physical properties do change, okay? So there is a change in the physical properties of the elements if we move from top to bottom. But now let us see in the periods what happened in the periods. We can see that, okay, so first of all, you know that as we are moving along the period, what happens is that, you know, in a specific period, if we are, for example, talking of the second period, so we can say that it has, in the second period, all the elements, they would have only two shells, okay. So the shell number is not different in any element which is present in the specific period, okay. So if you are talking of the second period, the all the elements that are present in the second period would have two shells. If you are talking of the third period, then all the elements that are present in the third period would have the three shells, okay. So it means that if we move along a period, all the elements would have the same number of shells. So it means that if the shell number is not changing, then how the size of the atoms are changing? Because you know that in the period, as we move along a period, the size of the atoms do change. And how they are changed, let me tell you. Okay, so as we move along a period, what happens is that every successive element gains one additional electron. And when the electron is added, the protons are also added. As you know, in order to balance the, you can say, in order to make an atom a neutral particle, okay? So you know that every atom has equal number of positive and negative charges. So if the successive element, or the element that comes next to the next to the other element, if the one shell is added, if the one electron is added, so the proton will also be added. So it means that now the charge is increased, so there would be greater attraction. Now in the nitrogen, for example, if the two electrons are added, then the two protons will also be added. This is just an example, okay? Not the two electrons are added in this nitrogen, okay? You know that there are different number of the electrons that are added, but I'm just giving you an example so that you can understand it very well. Now here you can see in the nitrogen, as we have taken an example, for example, that the two electrons are added here. So it means that the two protons will also be added, and this would increase the charge on nitrogen. So that is how the attraction of the nucleus for the valence shell electrons would be increased. So that is how, what you can suppose, what would be occurring inside the period. As we are moving along a period, the size is increasing or decreasing. So the size is actually decreasing. Why decreasing? Because the more we are moving towards the successive elements, the more is the charge increasing, and the more is the attraction of the nucleus for the valence shell electron is increasing. That is why it will attract it more towards itself, and that is why it would be reduced in size, okay? So it means that if the size of the atom is decreasing, then what we can say, that the physical property is also changing. Okay? Okay, sorry. This is not increase, that is, you can write there's a change, okay? So here you can see that the physical property is changing, okay? So now I hope you understand this. So it means that, let us summarize this condition. So the chemical property, as we were moving from top to bottom in a group, what was happening? The chemical properties do not change, but the physical properties were changing. But as we move along a period, both of the chemicals and the physical properties, they change. Okay, so thank you.